Hello everybody, welcome back. Today we're just going to do a quick review of these LED light bars that I just received from Banggood this morning. Not going to do anything too complicated with them today. We're just going to have a look at them, kind of evaluate their quality, do a little testing and maybe some math if we're feeling up to it. So yeah, I saw these on Banggood. They were on special. First impressions, not so great. They came packaged like this in this bag. I just startled my cat. So there was absolutely no structural reinforcement whatsoever in the packaging, just some squishy foamy stuff wrapped around the LED light bar, and that's it. It probably would have been better if they had stuck this in like a poster tube or a box or something, but just wrapping them in the foamy stuff and shoving them in a bag, not so impressed with that. Second impressions, really kind of very flimsy construction. This lens is all scratched up on the top here. I haven't looked at the other ones, but this one's kind of mangled up a little bit on the top, and it's like not made out of a particularly sturdy material. I kind of like the aluminum channel that the LEDs are mounted in. We'll take a closer look at that in a minute, but it's got these nice deep veins that I figure could act as fairly nice heat sinks for the LEDs. Now this is a 12 volt unit, so I've got 12 volts set up over here on my little power supply. Let's have a quick look at what they look like on. Nice warm white there. I hope I'm not washing out the camera too much. We'll tilt that off to one side. That's actually, I don't mind the coverage on that. That actually projects a rather nice beam of light. The flimsy plastic lens seems to do a fairly decent job of diffusing the LEDs despite being so flimsy plastic. So let's have a quick look inside. So I think we can just pop the, yep, those will just pop off like so. And inside we find a piece of rigid, well, rigid-ish, aluminum core PCB set up in little 12 volt arrangements with a 390 ohm, or sorry, 39 ohm resistor with each group of LEDs. That's a really interesting value. I think we are going to have to do some maths in a bit. Can I have a piece of paper? Here we go. So we'll set that aside for a moment. So that's kind of interesting. There's a logo on these little boards that has been masked out. That's interesting. Looks like 500EA or something. I don't know if you can see it on camera. I'll kind of tilt this around a little bit, but there's kind of a little bluish splodge on these boards that has some sort of logo on it. It's interesting that that's been masked out. Anyway, so I'm just going to take some readings off of these LEDs. Oops. Put the correct polarity on the LEDs here. Hopefully that's not swamping you guys out too much. Actually, what I can do is I'll just cover up. Oh, that's not going to work. Never mind. So hopefully that's not too washed out. And we'll go to our volts setting here and take a quick reading off of one of these LEDs. So we've got pretty much exactly 3.2 volts. I got my polarity backwards, but that's not a big deal there. I'll just switch those around. And we've got 3.2 volts going across the LEDs there, and across the resistor we've got across the resistor I can't really get a very good reading across that resistor. That's interesting. I'm just getting kind of a random mess. But we can do the math on that as for what we should be seeing across that resistor, and then we'll do a little bit more math to figure out the rest. So, just turn this guy off real quick. Actually, we'll turn these off too, so that they stop blinding me and they stop washing out the camera for you guys. So we've got each of these boards is a 12-volt board, and we've got three LEDs and a resistor. Each of those LEDs seems to be dissipating 3.2 volts times 3. So I'm just going to reach over here and grab a calculator. You'll notice I cracked my cell phone screen. I'm very angry about that. Gonna have to order up a replacement screen once I can afford it, and well, actually probably do the repair here on the channel. Why not? So we've got 3.2 times 4, go away messages. Oh, sorry, 3.2 times 3, because there are 3 LEDs per 12-volt section. So that's going to be 9.6 volts. So across that resistor, so we should be seeing about 2.4 volts. So what did we say that resistor was? We've got, the resistor has 3, 9, and 0, so 3, 9 and a multiplier of 0 makes 39 ohms. So we've got a 39 ohm resistor. So let's figure out what the current for each of those 12-volt sections is. We know the current is V equals IR. So we'll plug in our known values. We've got 2.4 volts across the resistor equals I is the variable we're trying to find times 39 ohms. So we'll do our algebra. We'll divide this side by 39 ohms. We'll divide this side by 39 ohms. So 2.4 divided by 39 equals 0.061 amps. So that's 61 milliamp per 12-volt section. So we're going to divide that by 3 to find out the amount of current in each LED. And we'll find out that each LED is running at about 20 milliamps, which is fairly decent for those LEDs. Now, just for fun, I'm gonna reach over here and grab a different lead for my multimeter here. Oh, or all tangled up. Give me a moment here. So we'll put these probes off to the side, and then we're just gonna grab these alligator clips instead. We'll quick stick those in. We're gonna crank over to the milliamp range, and we'll see if our math holds up to the actual readings here. So I'm just going to hook my meter in series with the circuit here. So we're going to take the positive lead and attach it to the positive lead of the power supply. Then we're going to take the negative lead of my multimeter, completing the circuit across into the positive lead of the LEDs here. And this is kind of a not so great alligator clip. Come on, cooperate. It's refusing to clamp on. There we go. I need to get some better leads at some point. And then we're just going to take and connect that across. So we're getting a reading across the entire strip here of 210 milliamps. 210 milliamps. We'll disconnect that. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. Let's see if that math holds up. 12 times 61 milliamps. Oh, 12 times 61 e to the negative 3 for... My math isn't holding up here. Let's see why this isn't matching up. Let's see, we've got 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 times 20 e to the negative 3. Okay, according to my calculations on the board here, I should be getting about 720 milliamp across. Oh, you know what? I wonder if that's the problem. Oh. You know what? I'm going to have to pause because I just realized that my little power supply here is only capable of putting out 500 milliamps. Although it's reading at 210 milliamps. This is very weird. That's very staunchly 210 milliamps there. Because our voltage is a little short? Nope. I just brought it up to 220. Very strange. Okay. I will be right back as I go and find myself a different 12-volt power supply that will put out the amperage that will actually power this at what I'm calculating out to be its correct current. So I'll be right back. Okay, and we're back after some brief troubleshooting and hooking up a 5 amp 12-volt power supply, which made absolutely no difference. I did manage to get a voltage reading across one of the resistors. I think I just had my probes wrong, and the resistor was exactly 2.4 volts, just like I predicted. The voltage across each of those LEDs is 3.2 volts across the entire thing. So that means that for each branch of the circuit, because what this is it's 12 of these series circuits wherein we have a 39 ohm resistor and 3 LEDs. And across that resistor we have the 2.4 volts at 39 ohms, and I'll just redo the math one more time here. We take the 2.4 volts because, once again, V equals I R. So we have the known voltage, which is 2.4 volts. And then we have the unknown current and the resistance, which is 39 ohms. So we divide by 39, divide by 39, and we get a prediction that, so we take 2.4, divide by 39, equals 61 milliamps. I finally figured out how to set my calculator to engineering science mode. Oops. I'll turn that off for a moment. So we should be seeing across each of these branches 61 milliamps. Now, because they're all in parallel, the current draw is cumulative. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these series circuits all in parallel. So they're all going to see the same voltage because they're in parallel, but the amount of current going into them is going to be cumulative. So we should see at 61 milliamps per branch, we multiply that by 12, and we should be seeing a current draw across this board of 738 milliamp, which we are not seeing. If this was pulling the current that our math is showing that we should pull, we're going to take that, multiply it by the 12 volts, we'd be seeing an 8.8 watt light bar. But instead, the current we're seeing is, on this new power bar, we're pulling 232 milliamps across the entire thing. And if we multiply that by the voltage, 232 milliamps, -3, there we go, times 12 volts, we're only looking at 2.7 watts. Now, I'm just going to quickly look at the order here, because I don't actually remember off the top of my head what the rating on these light bars was supposed to be, so I'm just going to quick hop into my Banggood app here. Bear with me a second. Alright. So it says that these are supposed to be 11 watts. We're nowhere even close. Even if we were dissipating the theoretical current of 738 milliamps for this entire strip, we'd only be dissipating 8.8 watts. And it says these are supposed to be 11 watts. That is blatantly wrong, especially considering it's coming out electrically at 2.7 watts. Now, I'm going to do some further troubleshooting. Actually, let's grab another one of these and see what the current draw across it is. We'll just grab another guinea pig here. Bear with me as I deal with the packaging. Oops. Just gonna sort of indiscriminately rip this apart. There we go. Okay, so there's another one. Again, very flimsy construction. They didn't even get the plastic lens mounted on properly on this one. So that's kind of disappointing there. What's going on with this? I'll mess with that later. That's not important. What is important, however, is, let's just spread these out a little bit here. Gonna set that back to the milliamps. Gonna trim these wires a little bit so that we've got a little bit more real estate to work with our alligator clips. There we go. Okay, so we'll take the negative lead from the new power supply and clip it on here, and we'll take the positive lead from my multimeter and clip it on over here. What are we getting on this one? Again, we're getting 230 milliamps, which means that we're only getting 2.7 watts out of these out of these light bars, which is way off from the advertised wattage that these are supposed to be running at. I didn't end up needing these. Why are they still out? Okay. So electrically, they're very disappointing. Their physical packaging is lackluster at best. I mean, like I said, I do like this aluminum channel because it's very, it looks like it'll dissipate lots of heat, although I just found out that it flexes quite a bit without the LED strip in there. Look at that thing. So yeah, if I was going to suggest whether or not you'd buy these, I'd say no. Granted, they were only a couple of bucks each, but I don't think it's an unreasonable expectation that if I buy a thing that says it's going to be 11 watts, that I actually get 11 watts of light out of it. So yeah, overall a pretty disappointing product. I'm not too sure why our electrical calculations aren't meeting up with the actual electrical performance of the thing. I'm gonna have to mess around a little bit. If I find anything super revealing, I'll do a follow-up video. But overall, that's yeah, pretty lackluster showing from those lights. Anyway, so I'm gonna call the video there. If you liked it, I'm actually gonna try to use a new feature from YouTube on this video. So if you click there, right on my new logo, that'll automatically subscribe you, and I'll put a video right about here. I don't know what video it'll be. Google's going to pick it for me based on your interests, so that'll be interesting to see what shows up there. And yeah, let me know what you think in the comments below, and we'll see you next time. Bye-bye.